in your handout. Does anybody need a copy of notes 2? Okay, if you need a copy of notes 2, come and get it. While you're here, come and get a copy of notes 3. We're going to talk about notes 3. So, number 9 is a little special. I'm on page 6. This is what number 9 looks like. Yeah. 5 volts, 9 volts. E1, R1, R2. Okay? We want to find the voltage in R1, the current in R1, the voltage in R2, the current in R2. So, the first thing I look at in the circuit is the polarity of that, or rather, whether the diode is forward biased or reverse biased. So whenever we have a circuit like this, the bigger power supply is going to take over, okay? It's going to exert its force. It's going to say, I'm in charge here. So this 9 volts is going to cause this diode to be forward biased because of the way this half of the circuit is hooked up. You see that? So then this is plus, this is minus, anode, cathode, and then plus minus. You see that? So based on that, let's figure out the voltage and current in R2. So that V1 is forward biased, which means that it acts like a closed switch with 0.7 volts across it. So VB1 is 0.7. How about the voltage at R2? Is it 9 minus 0.7? $8.3 volts. Everybody see that? So I'm looking at the right half of the circuit. I'm isolating it, and the 9 volts will cause the diode to become forward biased. And when it becomes forward biased, it will allow current to flow, and there will be a 0.7 volts at the diode, and the rest of the voltage is at the resistor. Now let's look at the circuit on the left. Here, I've got 5 volts plus minus, and I've got R1 plus minus. So what I'm going to do is I'm going to use Kirchhoff's voltage law, and write the voltages on the left side. So I've got 5 volts is equal to the voltage at VR1 plus the voltage at the diode. Everybody see that? So on the left side, the voltage supply should equal to the voltage drops. So one drop is at R1 and the other drop is at the diode. So I know the voltage at V1. It's 0.7. But look at the polarity. This is plus minus. Normally that a voltage here would be plus minus, but it happens to be minus plus. So this is the tricky part. So I've got 5 volts is equal to the voltage at R1 plus a minus 0.7. Okay? Why minus 0.7? Because of the effect of the right circuit and causing a 0.7 volt drop here with the polarity plus minus on the diode. So when I look at the left side, that's what happens in the voltage at D1. It's minus plus. Plus minus, normally it would be plus minus here, but it is minus plus. So that's why I have to indicate it as minus 0.7. So that gives me a VR1 of 5 minus 0.7, which is 4.3. So because I've got a diode in this circuit, it makes this circuit special. It behaves special. And therefore, I can now calculate IR1 here. Both are 1K and 1K. So that's 4.3 over 1K, or 4.3 million. Okay. Over here, on R2, I should have finished this, is 8.3 over 1K, 8.3 million. So this is a little unusual, the way the circuit behaves because of the diode and the way that it's forward biased by the 9 volts on the right side, causing the voltage on the left side to be seen as a negative 0.7, and that's what I used then to find the voltage at R1.